Hello. So in the previous video, we stopped in a use case wherein we were thinking if there was a better way to get this done and optimize this particular logic further. So let's continue from there and see how it could be done. So if you take a look at line 17, 19, and 21, they are exactly the same. The only thing that we're doing different between those lines is doing this increment operation. So what if there was a way, wherein we didn't have to execute these lines again and again, but just execute these two things and somehow get this kind of an output. So this is where the concept of looping comes into picture in C++. So looping is a concept wherein you kind of do some operations, execute some lines again and again in a loop until a particular condition is met. So you can imagine something like a flower bracket of being present over here. So anything that is there within these two flower brackets will be executed again and again and again until a particular condition is met. So this is the approach of looping. And in C++, there are different types of loops: for loop, while loop, do while loop, and so on. So in the scope of this video, for whatever we want to achieve, we will just visit something called as the for loop, of how the for loop works and how we can use a for loop in order to get this kind of an output in a better way. So before we understand the syntax of for loop, what we can understand here is what are the kind of operations we are doing. So the first thing that we are doing is we are doing some declaration of a variable, assigning some initial value to it. Then we are printing something. Then we are incrementing, and then we did again and again. And we wrote this a few more times previously because we knew that after count hyphen 3 is printed, we want to stop. So there is some kind of an exit condition also. So just to summarize whatever we discussed just now, let me add a comment and let us discuss those steps, okay, of whatever we are doing. So firstly, what we are doing is declaring and initializing. Okay. Second thing that we are doing is doing some printing. And the third thing that we are doing is incrementing. And we are checking uh, or let's say some exit case. Okay, exit case. Okay, that's all. So in the for loop also we are going to do exactly the same things. So let's write the for loop condition. So the syntax for that is you just have to tell for and open a common bracket. And the first thing that you're going to do is declare and initialize. So just take this from here, cut, and you can paste it here. So this is the first condition that you're going to do. The second thing that you're going to do is immediately after this is executed, the next thing that we have to do is we have to check for the exit case over here. So that is, as long as the variable is less than or equal to 3, we want this loop to run. Okay. So first this will be executed. The variable is declared and initialized to 1, and then it will check for the exit case. Okay, so now variable value is 1. 1 is definitely less than or equal to 3. So we can proceed, we can loop. So the control will come here, it will print this. Now this is something we are doing for each and every iteration. So what we could do is we can just cut this and put it here. So that's all. That's the syntax of our for loop. So after this count line is printed, we will just increment the variable because of this condition over here. And then again, we will come back here. We'll check the exit case. If it is satisfying, we will go, we will increment, check, print, increment, check, print, increment. So that is how the loop is going to go. You can note by now that this particular initialization, this particular declaration executes only once, not again and again. It's only for the very first time that this declaration and initialization will execute. So just let's run the code and see how the output is after this change. So yes, as you can see, we are able to achieve whatever we intended to. So this is the concept of for loops in C++, and this is how you can use it. Just so you know, you don't have to do the declaration here itself. What you can also do instead is, if you have something already declared, let's say something like this, then that's also totally fair, that you can have the declaration but initialize over here, and still it's going to work. So just let's run once again and confirm that, yeah.